Hi everyone, it's Coach Fred here, and this is actually a 2020 version of 9.4 Congruent Arcs and Congruent Chords. So if you're on my YouTube channel, there's an older version, but this is a better one, I think. Okay, so today we're going to be talking about circles again and arcs and chords. So it is important to know that if I have an arc on a circle, an arc is just a part of the rotation of a circle. Okay, so here we got. This is an arc, arc AB, and we write that as AB with the arc symbol above it. Okay, so if I'm in the same circle, or I'm in congruent circles, and I have another arc here, we'll call it CD. If these arcs are of equal length, okay, we say that they are congruent, okay? If I connect their endpoints through the circle, making a chord in the circle, connecting them, well, those chords would also be congruent. So congruent arcs have congruent chords. And vice versa, the converse of that would also be true. Congruent chords then would have congruent arcs. That should kind of make sense to you because if you think about it, the distance away from them, if they are the same rotation, then if I connect their endpoints in like a segment form, it should be equal. All right, so there's some other theorems that come from this that I want to kind of talk about. A diameter that is perpendicular to a chord bisects the chord and its arc. So let's draw a picture of this. I'm going to take a diameter. So I'm going to, you know what, I'm going to actually use this symbol, the harder one. I'm going to put a diameter right in my circle, okay? And then I'm going to draw a chord. A chord is going to go from one side to the other. So I'm going to do, and to make this a little bit easier, I'm going to color that chord. I'm going to make it red. Okay, so here we have a chord, and if we know that that diameter, there's my center, if that diameter is perpendicular to the chord, then it is cutting that chord in half. Well, let's see why. You guys have gotten really good at that oh so cool isosceles triangle. How would we make an isosceles triangle here? Well, we've been talking about in class that it's really nice to be able to think of radiuses. If I draw a radius from the center of the circle to the endpoints of the chord, all radiuses are equal. So I've actually created an isosceles triangle. And remember, if we have an altitude in an isosceles triangle, then it bisects the side. So that's why if a diameter is perpendicular to a chord, it bisects those two sides. It bisects that chord. Well, congruent arcs have congruent chords. So if we know now that this arc and this chord, they would have to be equal, then these little pieces would also have to be equal. So there's a lot going on here when I put a diameter through a chord. All right, we're going to be using that. And then the last thing I want us to think about is that in the same circle or in congruent circles, chords that are equally distant from the center are congruent. Okay, so let's think about that. Here I have a chord, and here I have a chord. Now remember, a circle is the same distance all the way around. So if I say that these chords are equally distant to the center, okay, and I'm saying they're equally distant by saying that these segments are equal, well, then they would have to be equal. If they weren't equally distant from the center, then one would either be shorter or longer. It would be like maybe here, or like I could say here. So the green and the blue wouldn't be congruent because one's closer to the center, so it got a little bit longer. Okay, so we want to feel good about these two theorems, okay? And so we can say the vice versa. Congruent chords are equally distant from the center. Okay, so let's look at some examples of what we just kind of talked about. So first of all, we say arc AC. So this arc right here, I'm gonna use colors here because the colors really help. This arc is 100 degrees, okay? And arc CD, I'll use a different color. This one is 75. Okay, so I'm going to find out everything I can. Well, if arc CD is 75, then I know arc AB is 75 because the chords are equal, so I know that therefore the arcs are equal. So that would be 75 degrees. Now, how would I find BD? How would I find this guy over here? Well, we have to remember that the rotation of a circle is 360 degrees all the way around. So I would add 75 and 100, which is going to give me 250. I would subtract that from 360, and that's going to give me 110. So I can see then arc BD would be 110 degrees. Okay, now it says find arc AD. Okay, so that just means I want to add the arcs together. A to D would be from 100. I could go actually this way, which would be 175, okay? So 175. And if I go this way, from A to B to D, it's bigger than 180. And remember, we said that if we used 2 letters, it was a minor arc, which is less than 180 degrees. So it would have to be going in this direction. All right, but arc BAD, that's a major arc. So it would have to go from B towards A all the way around to D. So that would be 100 plus 150, which is 250. So you do have to read the letters very carefully. All right, let's look at another example. Here I have arc CB is 110 degrees. Okay, now remember, we already talked about this. This angle A is on the circle, so we call it an inscribed angle. An inscribed angle. And we learned that an inscribed angle is half the measure of the arc, so it would be 55 degrees. I'm just putting that there for you as a reminder. That's not what this question's asking. It's asking you to find arc AC and arc AB. Well, I can see that the chords are congruent. These chords, which means the arcs are congruent. So if I know that what's left is 110, I can do 360 minus 110, which gives me 250. And since they're equal, I can take 250 and divide it by 2. So 125. So each of these arcs is going to be 125 degrees. All right, then I want you guys to all go through and add up the arcs and see if you can get it. We'll go over that in class tomorrow. All right, so these chords about theorems that I just went over, there's just a recap of it. A diameter that's perpendicular to a chord bisects the chord and its arc. So we know that these are going to be equal and these are going to be equal. Again, it's just a review of what I just went over in the previous pages. All right, in the same circle or congruent circles, chords that are equally distant from the center like this, these chords then would be congruent to each other, okay? All right, let's apply that. So here we've got a couple things we can apply here. So we have a circle A. I see that SQ is 12 and AT is 8. And it wants us to find PR, okay? All right, so if I want to find PR, I want to find the whole diameter. Well, the first thing I can see is that it's this the diameter is perpendicular to chord SQ, so it's bisecting this. So then I know that ST is 6. I can see then that I have a right triangle, and it is a Pythagorean triple. So it would be 6, 8, hopefully you're seeing it, 10. Okay, so now the radius is 10. So that means that AP is 10 because it is a radius. So then AR has to be 10, so then PR would be 20. See, got to look for it. Got to look all over for those different things. All right, we see that arc EF is 86 degrees and it has a length of 10. And let's see what we've got here. We've got that this is 5. We have a diameter that is bisecting a chord, so we know that it is 5 and X are equal. So I'm going to let X be 5. That also tells me that these guys are going to be equal, but I need to find the whole arc. Well, if the whole length of BA is 10, then it's equal to EF, even if it doesn't appear to be. So that makes this entire arc 86. And so the value of Y would be 43. All right, so I'd like you guys to try 3 and 4, and we're going to stop after that. We are going to do the remaining examples in class tomorrow. So just try 3 and 4, bring them to class, and we'll go over them tomorrow. Have a great day.